problems are not that bad if you know how to use your calculator. Now, I really am not going to be happy today, am I? So, does anybody have anything official from the university that says we're not having classes Friday? Because I do not have anything. But I've heard something that suggests that, and I think it's baloney. I don't know if your other classes are making plans. What I will do, and I did this yesterday because I had a fever. What I will do is, if it really is rotten, I will do the course by Zoom online. How many are okay? You better just look around. How many are okay with that on Friday? All right. Now, I'll come in if it's not that bad, but what I'm trying to do is I don't want to ditch you, and not teach. But if this is like giving an indication of what's coming, I'm really not looking forward to this. Has anybody been in a real hurricane in here? All right, well, I have too. And the last thing I'm going to do is drive around if we have 100-mile-an-hour winds, like Montgomery stuff. I don't care what the university tells me. So that's sort of my ideas and thoughts. Yes, sir.
If you do come in on Friday, would you still do Zoom as well? Wow.
Jeez. Yeah, I guess I can, but I'm gonna. I can do it. I can use that laptop to do Zoom for the whole class, and you can record the lecture and put it up. If that's see, if it's Zoom, if I'm doing Zoom at home, I just give everybody a Zoom link and I do it, and I have a doc cam at home. I've had to teach with Zoom during COVID. I'm not a fan of Zoom, by the way. The real problem is the students can't interact very well. In a class this size, it's hard to get an idea of what in the world you're thinking. Most people have their cameras off and everything. You don't know who. You're talking to a wall, basically. I'm not a Zoom friend. I mean, I don't mind it for faculty meetings and stuff, because everybody has to have their camera on. You can see if they're looking at you, if you said something stupid. But when all the cameras are off and you're talking to a screen, you feel like an absolute moron. It's like, why not talk to a wall? It's probably about responsible. Anyway, that's my thoughts on this. So it's going to be a fun class, isn't it? A lot of thunder. And I hope the power doesn't go off. By the way, last night the power went off in my neighborhood for about an hour and 15 minutes. If that's an indication of what's coming, I am not going to be happy at all. Anyway, so let's start with questions about this. Now I got that out of the way. Any homework questions? Please make sure you know how to use your calculators. I figured today would be the day that if you didn't know how to use your calculators, I literally team you up with people that do. That's what I do in this class, because this is the biggest problem, is people are unfamiliar with using your calculators correctly solving this. How many try these problems? Please just give me an idea. Now, if you haven't, for heaven's sakes, now is the time. Now is the time. Okay. Do you have one you'd like me to do? Anybody? I'll pick it. Yes, sir. All right. All right. Now please get your calculators out. If you haven't done this, please, I implore you to do this. This is problem 513. That's not, all right. I'm going to show you how I would start off doing this problem. Some of you probably see this already. And it's not meant to be a difficult problem at all. First thing I would do in a problem like this, anything you can combine and reduce the complexity of this, I would do. What? Oh. All right, so I'm going to ask you this. Can you all see it in the far back, by the way? I really don't want to yell. With me? All right, right off the bat, look at the series elements here. I got plus J2 minus J4. If you add those up, you get what, class? Plus J2 minus J4, you get minus J2, don't you? How many see that? That would indicate a capacitor. What I'm going to do is just make this, bless you, minus J2 ohms, and get rid of that. Does everybody see this? I'm just showing you. Try to reduce complexity. Everybody see this right here? Now the next step over here, what can I do? Just look at it. Can't read my writing. That's minus J4 and plus J8. Class? Plus J4. All right, now a plus J is an inductor, a minus J4 is a capacitor. So plus J4 would go here. Everybody agree with that? I'm going to show you the next thing. Just take a moment. Yes, sir.
Can you repeat what you said? It's plus for an inductor and minus?
An inductor always has a plus J sense of impedance, a positive J. A capacitor has a negative J sense, or a 1 over J. Y'all follow? I'm just trying to be clear about this. Please don't get behind me. All right, now, that's the first part I would do. Next, I look at this. How many see, if we're talking about the resistance between, or impedance, input impedance here, that 1 ohm and that 1 ohm are in series. How many see that? Can you all see? You see it, class? Or not? Over here, guys? All right, if you do, I mean, I assume you do, why not just get rid of 1 because it's not going to change things. If it's in series, just make this 2. This is how I would do it. You could put the 2 up here, doesn't matter. Now, obviously, now, here, get your calculators out. At this point, you take a look. Does everybody see we have 2 parallel impedances? Show of hands. Can you all see that? The first impedance is this, and you say, but it's got 2 numbers. It's a complex impedance. And this, there are 2 impedances. Anytime you have 2 impedances in parallel, you can add them, and I'll just write this down. Whenever you have 2 impedances in parallel, like such, and it doesn't matter what they are, if this is Z1, and this is Z2, then the total impedance right here, Z parallel, call it ZP, can be done as saying it's 1 over Z1 plus 1 over Z2. Does everybody follow me? It's just like resistances. If there were more in parallel, you would have plus 1 over Z3 at the bottom. But if you look at this right here, let's say we multiply both the top numerator and the denominator by Z1, Z2. You all with me? Then on top, you get Z1 times Z2, and on the bottom you get Z1 plus Z2. Take a moment and convince yourself. How many see that? Now either one gives you the right answer. Do you see it, guys, or not? In the far back, can you understand it? All right, so what would I do here? Well, I don't have your calculators. Probably this, just for convenience at this point so you can't make a mistake. So I'll call this my Z1, and this my Z2, and I'm going to get the parallel combination of those. Z1, well, I'll call it Z1. The symbols usually are Z1, Z parallel equals Z1 in parallel with Z2. And that would be equal to Z1, which is 6 plus J4. Now get your calculators out, you can do it. They'll do this very quickly. It's times the second one. 3 minus J2. I'm so glad I'm not outside. Over the sum of the two. 6 plus J4 plus 3 minus J2. I'm going to stop there before I go any further. You understand what I'm doing? Everybody? Now get your calculators up. They'll do this that quick. You enter those two values. If you have memory storage, and I'm sure you do, just put the first impedance in the first memory storage, second impedance in the other. Recall 1 times recall 2, right? Use that, divide by parentheses Z1 plus Z2, you'll get it. If you look at this, I'm going to ask you if you see this. Can you see at the bottom we've got plus J4 minus J2? Isn't that just J2 class? Can you all see that? You got J4 minus J2 is plus J2. So I'm trying to show you as far as what it actually comes down to. And then I got 3 plus 6, which is 9 ohms. So on the bottom, you can just as well put 9 plus J2. And if you haven't seen this done in a while, I'll do it for you. All right, now I got 6 times 3, 18, right? Then I'll do the last one. I have J4 times minus J2. Well, J times J is minus 1. With a minus sign is plus. 4 times 2 is 8. Then I have, if you look at this, I have J4 times 3 is J12. And then I have 6 times minus J2, which would be minus 12. So that goes away. So I have 18 plus 8 over 9 plus J2. And 18 plus 8 is 26, right? Everybody? Guys, so I'm just going to put 26 in. Let's see what I get, and then you tell me what you get. So what do you get for that? Now, I can go ahead and multiply the top and bottom by the conjugate of the bottom's value. The conjugate of 9 plus J2 is 9 minus J2. And if I multiply top and bottom by that, I would get a real and imaginary part. But I'm going to ask you to use your calculators now. Please get them out and tell me the value. Give me in terms of a real and imaginary value. Anybody? Just give me what you got. Please. Do you have a calculator? Go ahead and do it. I'm just trying to encourage people to do it. I'm not trying to force you into doing something you don't want. Yes, sir. What'd you get? Does everybody understand this problem?
I got it right
What do
here.
you-
2.75294 minus
Well, hold it. 2 points. Let's just 2.75.
minus 0.61.
Minus J 0.61.
61.
We'll call it about that. I'm roughing it. All right. How many got that? Did anybody not get that with their calculator? Now try it. Make sure you get it. You guys get it over here? You got it? Let me know. Did you get it? It's important that I know. I can't help people if I don't know what you don't know. Profound thoughts, right? That's deep, man. All right. Try it. You got it? Is that the right answer? No, when we're not done yet, what do we need to do? Right? We didn't add the 2 to it. Do you all follow me on this, class? So the actual Zn here would be what? This one, it would be 2 plus 2.75 or 4.75 minus J 0.61 ohms. Is that what he has in the answer? Because I don't know. Anybody confirm or deny that?
Yeah.
Is that what he's got? All right. I mean, it's rough because I kind of knocked off a few things, but that's about right. You agree? Are you all with me on this one? Now, I really, please take your calculators out and do this. I'm imploring you, I can't beg any better than I am, because this is what kills people. And I will have people tell me, but this is the right equation. But the answer is wrong, and you're engineers, you're not idealists. You have to get the right answer. That's the reason you're paid these huge salaries, because you get things done correctly. You're not salespeople that just talk a good game. You have to be able to do something. Everybody with me on this one? All right. Yeah. Did you have a question? No? Anybody else? Comment, question before we move on. I want to do a few of these. All right. You got another one for me? Where we're at? Anybody? I mean, I didn't give you too many. They're all the same type of thing. Just adding resistors and capacitors and inductors in parallel and series. That's all this is, but you have to be sure you know how to do it. And your calculators are your best friends or worst enemies. If you know how to use them, they'll just destroy this. They'll do it in a heartbeat. If you don't, you'll be so clumsy on a quiz, you won't know what to do. You don't know what you don't know. So please use your calculators. So another question, anybody? Yes?
Do you want us to give answers in that form or in polar form?
I would ask you specifically, for an impedance, if I ask an input impedance, it would be real and imaginary, as it is there. It's called rectangular form. If I want magnitude and angle, typically that's for voltages and currents. And I mean, your calculator should have a simple two-stroke or two-button command to convert from one to the other. And I don't, everybody here uses TI, except for that kid. And I mean, I was raised on HP, so I can't help you guys. I mean, I can, but I don't know your calculators. Every calculator is a little different too. HPs are much different because they have a different type. They have what's called a last in, first out. I think they call it reverse Polish notation, literally. That's what it's called. All right, I want to do at least one more of these. I want to pick one that's representative. Does anybody have one for me? I'll find one. There's a lot of good ones. Is this supposed to just sustain for the rest of today?
I think it's still like something, like, we're gonna bet with it for a really long time.
Well, this thing hasn't even made landfall.
I was looking at the radar earlier, and it's just a massive sphere of red sitting in the Gulf, heading straight towards us.
Yeah, that always makes people down in Florida feel good. One of my friends, one of the students I know, undergrad, was talking to me and his girlfriend's in Tallahassee, Florida, where it's supposed to hit. And he's trying to get her, come on, get out. You'll leave before it gets that bad. All right, so I'm going to do another problem. Does anybody have one they want me to do? I'll do one with a few more things added, because the only thing I needed you to do is get familiar with how to calculate the complex impedances. Now I'll take you to the next level. I think all those problems are the same as what I just did. You're either combining in series and parallel, or just adding up everything. It's not hard. The next thing here would be logical. Think about resistors. When you learn how to add them in series and parallel, what was the next step usually in the process of understanding? I put a source in, and I would ask you for the current or the voltage somewhere. Do you all remember this? Now we'll do that. Now this will be a little more involved, but you should have no problem if you understand this method. So I'm going to do problem 5.21. And I ask you to just take a look at this. It isn't hard, but I need to make sure that you understand this. Now here, there's a source. Can everybody follow me what I've done? Now be attentive here. I'm trying to give you some tips that'll be useful. If I look at this, and let me erase that. When I look at this right here, to get this voltage, I know one of the voltages, it's 6 volts right here. This voltage I don't know, right? Y'all see this? Now you can also say, well, that voltage is also across all these elements, right? You can do this a couple different ways, but the real thing you should notice right off the bat is this is a single loop circuit. Can everybody see that? There's only one loop, which means you can do this problem a variety of ways. You can find the current, then multiply the current flowing in or flowing through like this element right here, and say that voltage between the minus and plus here would be the voltage here plus 6. And I'm just talking kind of casually. You can do it that. Another thing is, you can say if you get the current flowing this way, well, this way, you can get the voltage between here and here by taking the impedance between here and here and multiplying it by the current. We'll get the current in a second. Y'all follow me? What I've just stated is you could really do current, or you could do voltage division. This is the source. The voltage you want is across this, which is in series with that. So it's 2 impedances in series with a given voltage source. Now I'm going to say this, it doesn't matter how you do it. But at this point, I'm going to show you what I think is probably the easiest to see. So when you look at this, remember what I did last time? I try to reduce the complexity. Do you all remember that? What can I reduce here? I think you'll get it. Anyway. Can you all see it in the back or not? Whenever I see people have this stare like they're not saying anything, that usually means they can't read it. This is not hard. What about these two guys? Can you read what that says? Anyone?
J2.
Everybody see it's J2, right? What about down here? What's that? And if they're added together, they are minus J2. So I'm going to kill this guy and make that minus J2 ohms. Right? Now, hear me. The total impedance between here and here would be this impedance plus 1. Do you agree with that? I'm just going to show you this. So I'm going to assume the current's going this way. From the there's only one source. It's got to come from the positive and return to the negative terminal. And I'm going to say that current I, right there, has to be equal to, if you think about it, what's the impedance between here and here? Well, it's 1 minus J2 plus 1. How many see that? Do you not see it back there, folks? Do you see it or not? Yeah, it's got to be what? From here to here, go around, 1 minus J2 plus 1, or really 2 minus J2. How many see that? So the total impedance is 2 minus J2, and there's a 6 volt source. Means the current going this way would be that voltage source, 6 at an angle of 0 degrees. You might as well just call it 6. If it's at 0 degrees, there's only one component. There's no other component. It's strict real. Do you all follow me in this class? Then you divide it by the impedance, which is going to be 2, and this is going to be 2 minus J2. Now I'm going to ask for this in terms of a real and imaginary part and a magnitude and angle. Now please see if you can figure out in your calculator how to get both. First, if I look at this to simplify, this is really 6 at an angle is 0 degrees. Divided by down here, the magnitude of this is square root of 2 squared plus 2 squared, or it's really the square root of 2 times 2 squared, or 2 times root of 2, and it's at an angle of minus 45 degrees. If you don't understand everything about this, take some time after class and learn what I'm doing. Can you all read what I put here? You're looking hard at it. Can you see it, read it, or not? If you can't read it, let me know. I'll write as large as I need to. All right, now I see this, well, 6 by 2 is 3. So I have 3 over the square root of 2, right? Because 6 and 3 would give me 3 square root of 2. That angle is 0 degrees. When this comes upstairs, it's going to be plus 45. So it's an angle of 45 degrees. And what do you get for that? Anyone? I mean, you can just put this in your calculus, tell me what you get in terms of a magnitude and angle. Anyone?
1.5 plus 1.5, J.
All right, that's 1.5 plus J 1.5. Both real and imaginary have to have the same value because the angle is 45. All right, but give it to me in terms of magnitude. It would be square root of 2 times 1.5, which is roughly
2.12.
about that, yeah? 2.12 at an angle of 45 degrees. Does everybody follow me on this? Now that's the current. Now we want the voltage between here and here. Now you can take that current, either form, and multiply it by the impedance between here and here, right? But you have to, since the current's going this way, you're going to get a voltage plus or minus. I want to do it this way. Do you all agree that that's the current, first of all? How many do? All right. What would the voltage, think of the way it goes. So what would the voltage here be, plus or minus? Well, the value is 1 ohm, right? It's 1 times the current. If I took this form of the current, 2.12 at 45, that would work, wouldn't it, class? Sure, I can say, well, that voltage right here is going to be simply 2.12. This is this voltage. 2.12 at an angle of 45 degrees. Now, everybody with me? Be attentive here. Now I need a voltage from here to here. What I'm going to do, and hear me, if you don't understand it, let me know. I'm going to start at the negative terminal. I'm going to go and sum the voltages from here to the positive terminal. That has to be V naught. How many understand that? Okay. So that would be equal to, now when I go from here to here, that's a voltage decrease. It went from a plus, came out a negative, correct, class? So it'd be minus this value, 2.12 at an angle of 45 degrees. What about from here to here? It would be an increase from the negative to the positive. Can you all see it in the back and stuff? I've got to make sure I'm talking to people that can understand what I've got. So this would be an increase of 6. Now this will bother you. Well, that's minus something at an angle. I'm used to seeing magnitude and angle. Y'all see what I'm saying? It shouldn't bother you. I'm going to tell you, there's a couple ways to do this. You can literally enter that in your calculator. It should work seamlessly. If you can put a value at an angle. Another way to do it, anytime you have a negative sign, you can do this, and I'll just tell you this. If I have let me put it this way. If I have minus A at some angle, that is the same thing as A at the angle of theta plus or minus, and if it's in degrees, 180 degrees, or pi radians. Y'all follow me? You can add plus or minus 180 degrees to that angle and get rid of the negative. How many know that? I mean, the MEs do this routinely, I'm sure you know. So let's talk about this. This is really, if I wanted to do it, I'm going to add the positive angle. V out would be equal to plus 2.12 at an angle of 45 degrees right here. And then you can take minus 180. It doesn't matter if it's plus or minus 180, plus 6. Now, when you do that in your calculators, I mean, your calculator should be able to do this without a problem. Remember, this is going to be an angle here of 45 minus 180, or think about this, minus quantity 180 minus 45. And what do you get for that? Plus. Can you give me a value for that? Anyone? You guys got it? Learn how to use your calculators, guys. I'm giving you a great opportunity to learn. Don't mess around with this. It'll bite you like you can't imagine.
It 1.004. Maybe.
Say again?
1.004.
Plus what?
That's it. I don't think I'm doing it right.
All right, now look, if this is causing you trouble, that's 1 times that current, right? Well, that current is right here, isn't it? 1.5 plus J 1.5, correct? So I can say my V out would be equal to, since it's minus that current times 1, it would be minus 1.5 minus J 1.5. That would be the voltage from here to here because it's a reduction. And we know the current is 1.5 plus J 1.5. How many understand that? With me? Are you guys okay with that? Now, to that I have to add 6, so plus 6. I think you'll see this here. So I have 6 minus 1.5, right? Which, do you see that or not? You're looking at me funny. Are you good with this?
Yeah.
What's that gonna be? 3.5? 4.5? I'm playing around. So this is what? 4.5 minus J 1.5 would be V out. Can you give that to me in terms of magnitude and angle? I'm just trying to do this, I'm trying to be a favor. Complex numbers trouble people until you work with them. Go ahead, say it.
4.743.
Okay.
And then angle at negative 18.4 degrees.
Minus 18 what?
18.43.
All right. So, anybody else confirm that? You guys get it? Now, is anybody having trouble with their calculator figuring out how to do it? Anybody? You are? What kind of calculator? Anybody have a TI-84 in here that knows how to do it? Anybody at all? Do you guys? You know it? Can you go back there and show them?
Sure.
Go ahead. He's back. Raise your hand. Go back there. Thank you. Anybody else? I'm really trying to help you. I can only help you if you help me. By the way, this probably is on YouTube. There's probably all sorts of discussions on how to do it. Just look, complex math, TI-84, complex math, whatever, TI inspired, complex math, what's the kind of 84? I'm pretty sure you know how to do it. All right, y'all with me? All right.
Yes.
Somebody had a question? Good, take some time, learn how to do it. Questions? We want to end base.
But then why won't that repeat? It doesn't connect to this. All you gotta do is go over here and change your
And then I did that. But then I got full. What did you? Yeah, what's that problem? Thanks, man.
So it has to be a degree. It has to be a degree.
Well, that one, that angle is 45 degrees.
Let it be in radian.
If it was like pi. So the next thing I'm going to do is 522. Now that could be voltage division, could do the problem I just showed you several ways. 522 is current division. This one, we have 2 amps. Let's see how you do this one. All right, can you all follow me on this? And here's what they want. They want this current right here. And they want it in the phasor domain. They want magnitude and angle. But I'm going to show you something about this. If you don't remember current division exactly, you'll be needing to know this very well, both current and voltage division, for the upcoming problems. This chapter, the next chapter, and really until the end of the semester. These things in Theven and Norton stuff are going to save your lives in a lot of senses. But when you're doing current division, what it says really in a nutshell is this: if you have some current I source, and it will have an angle, just leave it as I source, and you have some impedance, and I'll call it Z1. Doesn't matter if it's polar or if it's rectangular. And you have a second impedance, Z2. And I want this current right here. I'll call it I2. Can everybody follow me what I'm after? I have a current, IS, and it's going into the parallel combination of these two impedances. Can you all see that okay? Everyone? Far back, guys? All right. Now, if you want this current, the way you get it is take the total current, IS, and you multiply it by the opposite impedance, Z1. And then divide by the sum. And that, in fact, will give you I2. Can you all follow the logic? How many understand that? Now, if you're wondering how that comes about, well, can you all see the combination of these two impedances, if they weren't parallel, would be Z1 times Z2 over Z1 plus Z2. Does everybody follow me on that? So you could say the voltage between here and here would be IS times Z1 times Z2 over Z1 plus Z2. That would be the voltage. And then, if you wanted the current through here, you would divide that by Z2. And that, in fact, gives you this. Does everybody follow me? Now, with your calculators, give me the answer that you get for this current, and I'll call this I2. So it would be the current, which happens to be just 2, which is great, because there's no angle. And then it's times the opposite impedance. Now, let me just stop here for a second, and have you stop. Can I simplify this, people? I want you to take a look. How many think I can? I'm not going to ask. How would I do that? Anyone? Yeah, what am I going to add? You're right.
You add the 2 with J. and then
That's minus J.
minus J.
Minus J plus J is, minus 2J plus 1J is minus 1J. You're right, absolutely right, thank you. And get rid of that guy. Everybody with me? What about these two? Want to do it again?
Do the same thing.
Yeah, and what is the result? Minus J plus 3 is plus J2, right? Y'all hear him, what he's saying? He's right. All right, so this is going to be J2. Now this always cuts down the amount of numbers you have to crunch. Y'all with me? All right, now if I want this current right here, which I do, I take the total current 2 times the opposite impedance, which is 1 minus J1, and I divide it by the sum, and I'll write it down. 1 minus J1 plus J2. Everybody follow me. I'm just doing what I said you should do over there. Everybody with me, class? Far back, I gotta make sure. Can y'all see it? Dude, I don't know why you sit so far away, but if your eyes work that well, I'm jealous. All right, now down here, I can do that addition stuff again, right? 2J minus 1J is just J1, right? Do y'all agree with that? Let me show you something. Everybody follow me? Now, some of you know this, but some of you don't. This is 1 minus J1. It's going to have a magnitude of square root of 2. How many know that? If you wondered what I'm doing, it's nothing magic. The only thing I'm doing is, if this is the complex circle, and this is the real, and this is the imaginary, or J, and if I look at 1 minus J1, 1 out this way, minus J1 here, that's the magnitude, that's the angle. It's going to be a minus angle. The magnitude is going to be 1 squared plus 1 squared square root, or square root of 2. The angle is 45 degrees. So I know this will be simply 2, and then it would be square root of 2 for this one. The angle would be minus 45 degrees. Downstairs, I've got 2 plus J1, same magnitude, square root of 2. The angle would be plus 45 degrees. Just try it yourself. I can see the square root of 2's cancel. When I take the 45 downstairs, upstairs, it's minus 45 is minus 90. So I get 2 at an angle of minus 90 degrees, or simply minus J2, and that would be the current amps. Now try it on your calculator, see if you get it. You can do it just with the fundamental values. Make sure you get the right answer. You're either going to get minus J2 or 2 at an angle of minus 90. How many got one of the two of those? Excellent. Do you all get them? All right, now what I'm going to do for homework is give you problems going to the next step, doing current division, voltage division, asking for things that you did with just regular resistances. Now the only difference is you're using complex resistances. You all follow me? And on Friday, no matter if it's online or in person, we'll take it from there. And please be safe. Don't get yourself hurt in this crazy storm. All right, I'll see you then.